Hey, g'day, it's Presser. Thanks for stopping by. Now I'm working on the Stuart Turner 10H model steam engine again today. Got a few minor jobs to do on that before it's finished, and then we'll put the engine together and run it on air. But before I do that, I want to show you the new sticker that I got. Now this comes from a channel called Cutting Edge Engineering. I'll put a link in the description below and also one up above there now. And if you haven't seen any of their videos, you're in for a real treat. Now it's basically a two-person operation run by Curtis and Karen. They work out of a shed not far from where I live, and the sort of work they do is probably rebuilds, refurbishment, manufacturing of parts and equipment for the mining industry and the heavy haulage industry. So a lot of the parts they work on are absolutely massive, and it's interesting to watch the way they manipulate and move those parts around, get them from machine to machine. And I wish I was 10% of the welder that Curtis is. What he can do with a welder is absolutely amazing. But the story to this was that I sent them a stamped self-addressed envelope and asked them to send me back a sticker. But they not only did that, but they sent me this lovely little package with a coffee mug and a biro, a few other bits and pieces, and a personal letter, which was really nice. And the thing I wish I could have done back in the 1990s when I was teaching students was to use Curtis as an example of someone who has a trade qualification and has been highly successful. And back at that time, the federal government and the state government were trying to encourage students to stay on to the end of year 12 rather than leaving at year 10. And it was like the golden opportunity was to go to university and get a university degree. But the problem with that is that you incur a student debt. It's something like 3 or 4 or sometimes 6 years before you start earning any money. Whereas getting a trade qualification means you're paid from day one, and often your employer will actually pay for your training. And that was, something I wish I could have done back then, because it was unfortunate, but a lot of students saw a trade qualification as like the lower tier of achievement through high school. But as we now know, a lot of the people earning the really big bucks have trade qualifications. So anyway, that's the story behind it, but I'll get this up on the door now and then we'll work on the engine. I've had to migrate onto a new door with these stickers. The old one is getting a bit full. I don't know, is that straight? I think that's straight. So there you go, Cutting Edge Engineering. Thanks Curtis and thanks Karen. So these are the jobs I want to do today, but they're in no particular order. This one is to fit the cleading to the outside of the steam cylinder. So the cleading is basically a protective cover that goes over the outside of the cylinder, and you may be able to see there's a void cast into the cylinder, and that would normally be packed with some sort of insulating material. Now, back in the bad old days, they would have used asbestos. These days you can use ceramic fibre-based products or fiberglass, or even just cloth would do. And to keep that in place, we would normally fit a sheet metal cover of some sort. Now, the material that was most often used back in the 1950s and 60s was a material called Russian iron. And Russian iron is sort of a soft steel sheet with a naturally occurring black finish on the outside, which was corrosion resistant. I believe that the source of that stuff dried up a long time ago and you'd never be able to buy it today. This is actually anodized aluminium sheet, and it's not typical. Normally it would be made of brass. Sometimes they would use wood planking over the outside of the cylinder to keep the insulation in place. But I'll have a go at using that. If it doesn't work out, I'll use brass. Brass is actually better because aluminium is a bit weird around steam engines. The moisture and the heat and the dissimilar metals means that you often get corrosion with aluminium. But I'll start with this and we'll make a pattern. I can always sort of duplicate it in brass if necessary. Now this job here is to finish off the eccentric, and what I had tried to do in the last video is to drill an oil passageway from this little reservoir here down into the bore of the eccentric. And because of stupidity on my part, I suppose, but just also bad management, I tried to drill this material with a 1/16 high-speed steel end mill in the Bridgeport, and this material is 316L stainless steel, which will work harden if you just look at it. And because I was doing it in the Bridgeport, I had absolutely no feel through the quill about how much feed I was putting on the cutter. Turned out I just sat there and rubbed, it worked hard in the metal and just burnt the end straight off the milling cutter. So I bought some carbide micro drills, and we'll try using these, but I'll use a different machine, and hopefully we can get that little oil passageway through there, and then that part is finished. The other job is to fit this little gland on the end of the steam chest. Now this was 2 extra parts that I made, and I did away with the original gland design that was in the drawings, but this needs to be bonded on with some JB weld and aligned and everything, and we'll put a fillet around the bottom. When that's powder coated, it'll just look like one piece. So we'll get that done. And the other job is to fit the gaskets. They were supplied in the kit, and we're also going to put the packing in the glands. Now this packing is a sort of a yarn. It's soaked in graphite and oil or grease, and what it does is it provides a steam tight seal around the piston rod and the valve rod, and also on the piston itself, and it's sort of soft and self-lubricating, so it's ideal for the job. So I've actually got some old stuff here that I bought many years ago, and this was what was supplied in the kit. So I'll get all of that done, but I think I'm going to start with this eccentric, and I'll get the worst job out of the way first. Okay, wish me luck. In order to continue this drilled hole that I've already started, I've got the part in the Sieg X3 CNC milling machine. And the reason I'm using this machine now is that the quill is a lot lighter on this machine, and you get a better sense of how much pressure you're putting on the tool. The problem with this material, this 316L stainless, is that you've only got to let a tool rub for just a second, and the surface of the part will work harden, and then you're just going to ruin whatever tool you're trying to use. So I think Sieg is a better option here. So I'm going to position the part in Y using the probe. I'll just use the probe to center the part. In X, I've just done that by eye, and I've set the angle up of the part so that the drill bit will follow the path at the edge of the rule there, and that will continue into the bore of the eccentric. So let's get it set up now in Y. This is a 1.6mm solid carbide micro drill. The original hole that I started was 1/16 of an inch, which is 1.58mm, and I'll use this one. If I break it, I can go down to a 1.5 and then a 1.4. If I break 3 drill bits, I'm just not going to worry about it. We'll just have a decorative oil port there. So I'm going to use a mist coolant, and I'm running the spindle at 1000 RPM. Damn! Okay, that might be the end of our oil port, I think. That just snapped off and it's in the hole. Oh, I can't believe it. Alright, I'm going to have a closer look, but I think I got zero chance getting that broken drill bit out of there. It was actually working, it was cutting, there was chips coming out, but yeah. Alright, this is going to end badly. Okay, all may not be lost here. Now I've had a good look down the bottom of that hole there with a magnifier and a strong light, and it looks like the bottom of the hole is clear. So I think when the drill bit broke, it just popped out of the hole, and if you look on the inside of the eccentric, there's a little dimple there. Now that's where the drill bit would have broken through the babbitt if I'd kept going and the drill bit hadn't broken. But I think what has happened is the drill bit caught on the edge of the stainless steel because of the inclined nature of the hole there, and it's just loaded up the drill bit and it snapped. But what I think I can do is get the Dremel and probably use a little tiny burr and get through that dimple, and that will communicate with the hole coming down from the oil reservoir. So I think I can save this. I was never going to scrap the part, but I was going to do away with the idea of having an oil passageway in there. But I'm going to try the Dremel and I'll get back to you. Now, you nearly got to see a grown man cry there, but I was able to save the day with this little tiny dental burr. Now, this is different to the one I used in the previous episode. It's more like a conventional end mill. So it's cylindrical in section, it's got teeth right on the very end, and I was able to pass that through the center of the eccentric, just on a slight angle, and just work away at the top of that little dimple there, and it only took about 2 seconds and it popped through. Now, the really good news was that the hole is clear. So when the drill bit broke, it must have popped out again, and that was the thing I was most concerned about, was that the drill bit would be jammed in the hole. But I can pass a piece of copper wire right through there now. I've blown that out, compressed down, it's completely clear. So that was exceptionally lucky. So I can breathe a sigh of relief. I'll put this part aside and we'll work on the cylinder now. But yeah, got lucky there, Mark. Doesn't happen all the time. This material that's supplied in the kit for making the cleading is about 3mm too wide, and it will need to be trimmed down to fit. And there are also 3 holes that need to be drilled in this sheet material to line up with these 3 holes here. So this is the exhaust port, and these 2 holes are for the drain cocks. Now, there will also be 2 holes drilled in these corners here for the 8BA round head screws, and they hold the cleading onto the cylinder. So to mark out the card, I'm going to put the cylinder directly onto the card, and I'm just looking over this side here to line it up. We'll get our steel rule on there. And we'll do that both ends. Okay, we can cut that with the sharp blade. Okay, now that's more than enough, and we can now carefully wrap that around the cylinder and just get an approximate length. So I'm just going to cut this slightly oversized. Now, if you mess it up, it's easy to have another go, and that's the whole point of this, is don't risk your nice material that's supplied in the kit. Do this, and then you can always sort of do it again if necessary. So if we put this on our aluminium stock here, it's actually very, very close to the correct length, but the width obviously has to change. So let me do that. I think I'm going to cut this with a knife. That's my wife just coming home. After you go over that about 20 times, it sort of scores deep enough that it should just break off. So with a pair of pliers, you just grab it and just flex it and it will snap through. But if you try and cut this with a pair of snips, it will curl up the edge and distort it. So doing it this way keeps your stock nice and flat. Alright, that can do with a nice like a sand along that edge, just get rid of the burrs. But that now is the right width. In order to hold the cleading onto the cylinder, the drawings specify 4 8BA holes drilled and tapped in the side of the cylinder there. So I did that on the Bridgeport, And in hindsight, I probably should have drilled those holes perpendicular to this tapered flange on the end of the cylinder there, so that they held the cleading tight against that taper. But I think this will be okay. I actually lined up the screws with the stud holes in the corner of the port face, and that meant that I didn't have to tap into a blind hole. It does give you a very short thread engagement though, but putting it anywhere else on the end of the cylinder there was really difficult. So what I'm going to try to do now is to roll this piece of stock for the cleading, and as you can see, it's got a big kink in it. That's how it was when I got it. I'm going to try rolling it over a mandrel, and I'll roll it in opposite directions to try and neutralize that kink there. So let's see how that goes. So this sheet stock is very, very soft, and it's rolling quite nicely around this chrome plated bar. So it's probably a bit smaller in diameter, but that's okay, it'll spring open. So I'm just going to do a bit of final shaping on this and we'll see how it fits. Okay, it took several goes with different size mandrels, but I got that fitting really closely now. I trimmed one end of the stock so that the edges line up with the port face of the cylinder now. So I'm going to go ahead and mark out all the hole positions using the surface plate and the height gauge, and I'm just going to work off the dimensions shown on the drawing, and that way I can be sure that I'm going to get the holes to line up within a couple of hundredths of a millimetre, because when I marked out all these holes I did them on the Bridgeport using the DRO to fixed dimensions shown in the drawing. Okay, I've got this assembled, and although it looks okay here, I know it's not right. The three larger holes, the two for the drain cocks and the exhaust port, the drill bit's wandered off centre, and I've had to correct that. I brought it back into the correct centre with a small needle file, and that means enlarging the hole to make it circular again. So I can take one of these drain cocks off and I'll show you what I mean. So you can see the hole is quite a bit bigger than it needs to be. But there is a boss on the bottom of the drain cock which covers that, so I think we're okay there. And with this exhaust fitting, this is temporary. I'll try and figure out something better than that later on. The 4 holes for the 8BA screws, they were perfect. And I may replace this cover with some brass sheet later on if I can find something the correct thickness. But for now, this is functional. It'll powder coat okay. I think I'm going to leave this, and we'll move on. We'll do the seam chest, then get everything assembled. The last thing I have to do here is to glue on this extra part that I made for the steam chest. So this is a departure from the published drawings. The original arrangement was to have a hex-headed gland nut that's screwed into a threaded section here. So I modified it. This is the part that I made. And it's just made of cast iron. So I'm just going to clean this. It's going to be stuck on with JB Weld, which means that I can powder coat over this later. So I'm just using some alcohol to get rid of the oil and the grime in there, so I get a nice strong bond. There's no actual load on this part. Right, got a bit of a fillet around the joint there, and I'll sand off the excess when that's cured. So I'll put that aside now. Oh, got something to show you too. Okay, just so it doesn't come as a surprise later, I did make new cleading for the cylinder. This is made of some thin brass sheet stock. It's a better material for the job and it fits way better. I just took my time and I double checked everything, and I was sort of a bit more careful about marking out the lines and centers for the holes. It's much easier to do it when the camera's not rolling. But there you go. It looks much better. Okay, as you can see, I got the whole engine together now, and I'd love to say this went together without a hitch, but it did not. It basically fought me every step of the way. And one of the problems is that you make all of these individual components and you check the fits and they all seem to go together nicely. But as you do more and more of the assembly, minor inaccuracies start to stack up. And by the time the whole assembly is done, it's quite stiff and tight. So it's going to need a bit of extended running, and I'll be using compressed air initially. And then we'll put lots of oil through it and we'll just let it run, and it should free up a bit. And another problem I had here is that the fasteners that came in the kit weren't specified in the drawing. It was basically a bag of studs and nuts and bolts and so on, but it didn't tell you where they went on the model. So this is what I ended up with left over. And some of these came from the kit, some were extras that I found in a scrap box. And one of the reasons that I had to use different fasteners was that I modified things like this big end on the connecting rod, modified the eccentric, so they needed different fasteners. And also in the kit, it didn't actually in the drawings, it didn't tell you how to fasten the cylinder to the trunk guide. And although there were bolts that were the correct length, you can't actually insert two of the bolts because one's underneath here and it's a very small gap, so you can't get it in. Another one around the other side here, which is hard to get in, so I ended up having to swap them out for studs, and even then I had trouble. This particular nut was rubbing on the surface of the trunk guide and I couldn't turn it, so I had to modify that. So yeah, it's just been a bit tedious really, but we're almost there. The last step here is to use this material to pack the end of the valve chest, and I think this stuff is like a hemp material, some sort of a hemp twine, and it's been coated in some sort of a wax or a grease, but it's nice and soft and you can wrap it around things like this valve spindle very easily. And I did this off camera because it's just tedious and fiddly and it's not very camera worthy. So the last step here is to cut the ends off and then poke it inside, and I'll just use a little probe here to push it in, and then I can clamp that in place with this bronze fitting. But I'll do that off camera, and then we're going to give this a run on air and we'll just see how it goes. Alright, stand by. Okay, that went together. These are 8BA nuts on studs here, and I ended up putting another turn of that hemp twine around the valve rod, and that meant that when I press this bronze gland into place, there is some clearance there, so that as that hemp material is compressed in the joint, you can still tighten these nuts further and provide a better steam tight seal as everything compresses up tight. So I'm going to get lots of oil in this now and then we'll give it a run. So I'm just using some of this very light sewing machine oil. I'm just going to put some directly into the steam chest. Okay, let's see what happens. Okay, that still feels fairly stiff, and you may have heard there's a slight knock at both ends of the stroke, and I can feel that as it goes over the bottom of the stroke and it comes up to the top of the stroke. So something is tight somewhere, probably in this junction between the actual end of the piston rod and the gland that's back inside the trunk guide here. That's where I suspect it is, and it's going to need a bit of fettling, like I say, to get that right. So at the moment it's not going to run at really low steam pressure, and you often see people test steam engines. They'll run them on a few pounds per square inch of air and they'll just tick over, and that's not going to happen with this engine just at the moment. But when I get this stripped down and inspected and cleaned up again, I'm pretty sure we can get that to happen. The one thing I was concerned about was that the flywheel would have a wobble, and there is a very slight misalignment in the flywheel at the moment, but I haven't tapped the key in all the way yet because I've got to pull it apart. So once all of the finishing is done, I put the engine back together, I'll seat the key properly, and then we'll do the final adjustment on the flywheel to make sure that that runs dead true, because that is one of the things that people look for most when they're watching a steam engine run. If the flywheel wobbles, you've failed. So I hope I can get that right. And you can see there's a little bit of black oil present on these parts at the moment, so it is wearing in. Metal is being removed at some point, and that's typical of this process of running the engine in. But yeah, it's just one of those things that you have to do. Okay, I'm going to finish up here now. I've got some little wildlife clips to show you, and in the next video I release, I'm going to be working on the die holders, and I'll make an announcement about the giveaways that I'm doing. So tune in for that. I've got some of the stainless steel 3D printed die holders to do. They're going to be interesting, believe me. And with my experience on this stainless steel part here, I sort of knew what to expect, but it still caught me off guard. So yeah, tune in for that, and I'll see you next time. It's Prezzo signing out. Cheers. This little guy was in the workshop. I just picked him up off the floor. He's got little bits of fluff caught in his claws. But this is a very young bearded dragon. These things grow to about a foot long, maybe up to 18 inches or 450 millimeters. When they're fully grown, they've got a beard underneath their chin, which they can sort of extend when they're threatened. They open their mouth, which is sort of bright yellow inside, and that sort of wards off predators. He's really cute at this age, but we'll let him go. There you go, little guy. Come on, scuttle off.